Hi everyone, Mrs. V here. Today we are going to learn about dimensional analysis. This is a method that we're going to use to convert units. This is going to be particularly important in gas laws to convert units of pressure, but also units of volume, and we're also going to need to do some converting of units of temperature. So let's get our whiteboard on and let's get learning. Dimensional analysis is also known as unit analysis and is often just called the multiply by one method. It takes advantage of the fact that we have equivalent units for the same quantity. So equivalent units, things like if we're looking at the quantity of time, 1 day is equal to 24 hours. So they are different units, but we're talking about exactly the same chunk of time there. And the interesting thing about that is if we look at 1 day divided by 24 hours, then we're looking at something being divided by itself because these are actually equal. So because these two are equal, then 1 day divided by 24 hours is equal to 1. Which means if we multiply something by 1 day over 24 hours, then that's the same as multiplying by 1. And that is the basis of using this method of unit conversion. It doesn't matter what quantity you're talking about. Here we were talking about an example with time, but you can do length. We're going to particularly be looking at pressure unit conversions. So it works across the board. Examples, how many meters are there in 0.125 kilometers? I know, I can hear you from here. I can do this in my head. I don't need some fancy method to be able to do this. Very true, but let's learn a method on an easy example so that we increase our confidence with it. So our equivalent units, if we're looking at meters and kilometers, 1 kilometer is equal to 1,000 meters. They're our equivalent units. So if we start with our 0.125 kilometers, I'm going to multiply by the equivalent units over each other. But I want to do this in such a way that I can cancel those kilometers out and end up with the units of meters. And to do that, I'm going to need to put the meters equivalent in the numerator and the kilometer in the denominator, because that's going to let me cancel the kilometers. From there, I'm going to end up with 0.125 multiplied by 1,000 meters, and the denominators now simply become 1. This was originally just over 1, and now that the kilometers has been cancelled, that's just 1. Multiplying that out will give me 125 meters. Easy, and yes, you could have done it in your head and you would have been very successful, but let's learn the method. Something that's quite often needed is a conversion between imperial and metric units. If you were looking at a document from America, you might have a measurement of 10.35 inches mentioned, and that means nothing to you. You need to convert that to centimeters. You can look up the equivalent units. There are equivalent units between imperial and metric for most quantities. So we are starting here, 10.35 inches. IN is the abbreviation for inches. And I want to multiply that by the equivalent unit over itself. But because I want to end up with centimeters, I'm going to put the centimeters in the numerator, 2.5400 centimeters, and the 1 inch in the denominator. Now my inches can be cancelled out, and I'm left with 10.35 multiplied by 2.5400 centimeters. And again, the denominator has simply become 1. And if I run that through the calculator, I'm going to end up with 26.29 centimetres. These significant figures here are controlled by the original measurements. So this is where we get that we should have our 4 significant figures. It comes from the original measurement. You should attempt with your conversion factors not to be limited by the significant figures in the conversion factors themselves. You can always look them up to more significant figures if you need. Here's a pressure example. How many kilopascals in 50.0 pounds per square inch? When I look on my bike tyres, it tells me to pump them up to 50 psi. I've made it 50.0 here just to make sure significant figures are not ambiguous. But PSI, pounds per square inch, sometimes you'll see that written LB. LB is the symbol for pounds. LB per inches squared, or simply just PSI. It's an imperial measurement of pressure. Okay, 50.0 PSI. And I want to convert that into kilopascals, the metric, or this is actually the standard unit of pressure. So I want the kilopascals equivalent. My equivalents are 101.325 kilopascals and 14.7 psi. You're always going to be given the equivalent units, and these might be on your data sheet or written in the question. We're going to multiply that by, I want to make sure PSI is on the bottom so it cancels out, and kilopascals is on the top, so that's what I end up with. So 101.325 kilopascals divided by 14.7 psi. And again, I'm just multiplying by 1. They are the same thing. They are equivalent units. My PSIs are now going to cancel out, and I will be left with 50.0 multiplied by 101.325 divided by 14.7, and this is going to be kilopascals. And if I run that through my calculator, I end up with 345 kilopascals. Sometimes it's not as simple as just one step. How many seconds in 24.7 days? Well, you could go through and work out how many seconds are in a day. Or if you're feeling, oh, I'm feeling a bit too lazy to do that today, I'm just going to run my dimensional analysis on it. So I'm going to start with my 24.7 days. And I'm going to think of an equivalent that I know with days. Well, I know that there are 24 hours in a day. So I'm going to multiply this by 24 hours over one day. And I put the hours on top and the days on the bottom because I want to be able to cancel days. From here, I'm looking for an equivalent for hours. Well, I know there's 60 minutes in an hour, so I'm going to put an hour on the bottom because I want the hours to cancel out. And 60 minutes on the top. Now my hours are going to cancel out. Almost there. Now I know that there are 60 seconds in a minute. I'm going to put a minute on the bottom so that the minutes cancel. There's 60 seconds. Cancelled my minutes. Now I'm left with something simple to just plug into my calculator. 24.7 times by 24 times by 60 times by 60 seconds. And the denominator has been reduced to 1 again. And if I ran that through, I get 2.13 times by 10 to the 6th seconds. Now, final example is converting between kilometres per hour and metres per second. And last year, you probably learned that the conversion factor was 3.6. You didn't question why the conversion factor was 3.6. You just went with it because it gave you an answer. If we run a dimensional analysis on this, though, we'll actually work out why that is the conversion factor. It's a little bit trickier than the other examples, though, because if I've got 15.25 meters per second, now meters per second really means meters divided by seconds. Okay, so now I have two units that I need to convert. I need to convert the meters into kilometers, and I need to convert the seconds into hours. It does not matter which one you do first, just pick one and roll with it. So I'm going to choose the meters to kilometers. So I want kilometers to be in the numerator in kilometers per hour. If I look over here at kilometers per hour, that's kilometers over hours. So I'm going for a numerator of kilometers, which means I want my kilometers and meters. 1 kilometer over 1,000 meters. This is going to give me kilometers at the top, and also my meters are going to cancel out. If your units don't cancel out, then you've made a mistake. And it's a good check. So now I'm good. But if I was going to multiply that out, it'd be 15.25 kilometers over 1,000 seconds. My units would be kilometers per second. I don't want kilometers per second. I want kilometers per hour. So I'm going to start to work now to turn that seconds into hours. So if I have seconds and I want the seconds to cancel out, the seconds are in the denominator. So I'm going to need my seconds. What am I doing here? I'm doing seconds. Let's do seconds and minutes. So I've got 60 seconds over 1 minute. That's going to enable my seconds now to cancel out. But now I would be, if I did 15.25 times by 1 times by 60 kilometers over 1,000 minutes, my units will turn out to be kilometers per minute. And I want kilometers per hour. So now I'm going to have to go, well, if I want to get rid of my minutes, there are 60 minutes in 1 hour. And I've done this in such a way that I want hours here to be in the denominator. My minutes will cancel out, and I'm left with a reasonably impressive product to perform now. 15.25 multiplied by 1 kilometer, multiplied by 60, multiplied by 60, and that is over, I guess this was originally over 1, so that's 1 times by 1,000 times by 1 times by 1 hour. And if I start to gather things together a little bit, I've got 15.25 here. 60 times 60 is 3,600. And then times by 1 is just the same. And kilometers over 1,000 and hours. Split it up a little bit, 15.25 multiplied by 3,600 over 1,000 kilometers per hour. Then what we'll see is 3,600 divided by 1,000. There's our 3.6. There's our conversion factor. And kilometers per hour. And if you actually want to run that through, it turns out to be 54.90 kilometers per hour. So I know that's a great load off your mind now, because you no longer need to memorize that the conversion factor is 3.6. All you need to do is a dimensional analysis, and you can work out, do that unit conversion without memorizing anything now. So that's a great relief. That's all I've got for you today, and I will see you in the next video.